Hey students, it's Coach Bryant. We're going to go over the vocabulary for tonight. This is Power Standard number 9. It's basically, we're going to get into algebra. So to start off, we're talking about the word variable. Now, most of you are already familiar with this. It's a symbol, usually a letter, used to represent an unknown number. So like x plus 1 equals x is our variable. And x could be any value. So an expression, a value stated using numbers, symbols, or functions. Now, this is kind of a difficult concept because you're used to just looking at equations. It's how you think about the many ways you can express yourself. Well, we can express values in math equally on a very complex way. So 2 plus 1. Well, you know what 2 plus 1 is. We could also express that value as 3. You could express that same amount as 4 minus 1. All of those three expressions, each of these is an expression, represent the same value. Now, an equation is when you take two or more expressions, you separate them by an equal sign, indicating that they are the same. So, for example, we'll use those above us. 2 plus 1 is equal to 3. This is an equation. It has an expression on this side and an expression on this side. Here's another one. 4 minus 1 equal to 3, but we could write the expression on the other side of the equation as 6 minus 3. So these are two equations, each having separate expressions on each side of the equal sign. Okay, moving along, we're looking at independent and dependent quantity. We're going to kind of look at these together. The independent quantity, also known as an input, can be any number you choose. The dependent number, also known as the dependent quantity, also known as the output, is the value of this number depends on what the input is. So I'm going to write independent here, and below it I'm going to write input. Now for this activity, I'm going to call my input, I'm going to use the variable x. And this is what you'll see in a lot of our examples and problems. The dependent or output I'm going to refer to as y. So let's create an equation like x plus 1 equals y. So in this case, y is dependent on whatever x is. So if x is 2, then 2 plus 1 is equal to 3. Now we could use any number, so if we said x was 35, then 35 plus 1, the output or dependent quantity would be 36. All right, sequence and term. Sequence and term. These might be new to you. Sequence is a list of numbers in a specific order, and a term is each input number in the sequence. Now, sequences, we usually represent them using tables. And a table might be horizontal, like this one, where we have x and y. And so if you have 1, 2, 3, any array of numbers in here, in any form, is the sequence, and each one of these is the term. So let's do another one. Sometimes tables are vertical. So I'm just going to make a vertical table. And in this one, we'll have 1, 2, and 3. So this whole thing and this whole thing, as it represents these numbers, is the sequence. And each of these represents a term in the sequence. Now, let's do one more example to show you what I mean, because it's not always this straightforward. So I'm going to create another sequence using a table, and I'm going to put 1, 5, and 13. So they're not always perfect. This is a sequence, and each of these is a term. Okay, the final two words, additive relationship and multiplicative relationship. Let's look at additive first. So let's take the equation x plus 1 equals y. This is an additive relationship, and I want to create a sequence to illustrate that additive relationship. So if we have the input 1, 2, and 3, and the output 5, 6, and 7, let's define what the additive relationship is in this sequence. So 1 plus what number is 5? 2 plus what number is 6? 3 plus what number is 7? In each of these, x plus 4 equals y. Okay. Now, even though it's called additive, we can also subtract in an additive relationship. So if I had this sequence of numbers, 1, 2, and 3, and the output was 0, 1, and 2, that equation, the difference is each time it subtracts 1. So you would have x minus 1 equals y. X minus 1, 1 equals y. So what I want you to do is come over here and write or subtraction. Add that, because an additive relationship includes subtraction. Okay? Multiplicative relationship. So let's look at this sequence. X and y. We have 1, the output is 5. 2, the output is 10. Can you guess what the output would be 3? Would be for 3? Okay? If you figured out it was going to be 15, you were right. So let's write an equation that represents this multiplicative relationship. So whatever x was, x times 5 equals y. Okay? Now, just like additive relationships can include subtraction, let's look at this. This is also a multiplicative relationship. We have x and y, and we have, let's write this sequence. This is a sequence 4, 6, and 8 for the input, and the output is 2, 3, and 4. Each of them got smaller, and each of them got smaller by half. So if the equation for this would be x divided by what? 2 equals y. X divided by 2 equals y. So what I want you to do is on your definitions, I want you to write or division. All right, students, we're going to move on to Power Standard number 9, equations with tables. This is the next, this is the legal size piece of paper. Let me kind of show you what I've done here. I have the full giant piece of paper, and what I did was I folded it over right below this example, and on the back are the practice problems that you need to do. Okay, the bottom two are really tough, but I know you'll be able to do them. All right, so we're going to do these two examples, and this is really an extension of what we just did a little bit in the notes. So in this lesson, we'll look at sequences in tables and make predictions based on patterns. That was supposed to be more than one prediction or predictions. So example 1, look at the table on the right, observe the pattern. Can you predict the output in this sequence for the 4th and 5th terms? Okay, you might want to pause it, and I need you to complete the table over here. Okay, complete the table. See if you can do it. All right, so I've got 2, 3, and 4. 1, 2, 3, 4, 5. So it goes 2, 3, 4. So you can make the prediction that as long as this is in order, that this will go in the same. It will go in order as well. And the difference between the input and the output on every single one of these is just it goes up by 1. 1 becomes 2. 2 becomes 3. 3 becomes 4. So 4 will become 5, and 5 will become 6. All right. So now we're going to ask this question of ourselves: is the output found by adding or subtracting to the input, the independent quantity? If so, this is called an additive relationship. If it changes by multiplying or dividing the input, it is a multiplicative relationship. So we're going to indicate if this is an additive or multiplicative. So what do you think? It's additive. Okay. All right. So can you write an equation to predict any position in the sequence? Let's write that equation. So in every single one of these, it was a change of +1. So all we need to do is write that x plus 1 equals y. Now you're going to see this on some tests. It says use this equation to determine the 11th term in the sequence. And what that means is, what if x was 11? Well, if x was 11, y would be 12. All right? And that is an example of an additive relationship kind of equation. Again, it could also be a situation where you're subtracting. All right, let's go to example 2. All right, we're going to look at this table to the right and observe the pattern. Can you predict the output in the sequence for the 4th and 5th terms? So we have the input, and we have 1, 2, 3. This is the 4th and the 5th term. And we have our output, and it goes 4, 8, 12. It's changing by a constant amount. Now, what's weird is if you look 1 to 4, it's like +3. 2 to 8, that's like +6. And 3 to 12, that's like +9. So that doesn't really give us a consistent pattern. But when you go 4, 8, 12, you see that every term changes +4. Now, if you think, every time it's repeatedly +4, that's repeated addition, and we call that multiplication. So let's think about times 4. 1 times 4 is 4. 2 times 4 is 8. 3 times 4 is 12. So that works for our rule. So 4 times 4 would be 16, and 5 times 4 would be 20. Now, since this changed by multiplying or dividing the input, it is a multiplicative relationship. It is a multiplicative relationship. Okay. So again, let's write an equation for that. Now, looking at this, even though every time it goes up by 4, that's repeated addition, it's multiplication. So we're going to have x times 4 equals y. So again, let's take this on. Use that equation to determine the 11th term in the sequence. All we need to do is plug in x for 11, multiply it times 4, and we'll have our y, which would be 44. Those are the two examples that we'll use for creating equations using the tables. Now, what we want you to do is turn the page over. You've got six practice problems that we want you to do, where you need to complete the table, decide if it's additive or multiplicative, and then write an equation for that table. Good luck.